Hello, I'm Gabrielle Taylor. I'm going to be doing homework for Part C. So we want to integrate into our block diagram. We want to integrate an integral controller. So right now we have a proportional controller, and now we're going to add on to it is an integral controller. So here's the block diagram. So we have the height set point going through, and then we have our comparator, and then we have our GC, which is going to have our integral controller in there. And then we have our GP, which is our controller process. And then we have our height coming out of it. So we know that our GP, which is our transfer function, is going to be k over tau s plus 1 to the third. And then we have is GC. So this is going to our transfer function with the integral controller. We have is our KC, which is our proportional controller, times 1 plus 1 over tau I s. Tau I s. So with this, so tau is the time delay for the integral controller. It is different than the tau that's in our process transfer function. That tau is a time constant. Tau I is going to be that time delay. So from this, we have is our transfer function of our open loop. That is going to be just everything that's moving straight across, which is GC, GP. And then we have our closed loop like we did in part 2, or part B, which was GC, GP over, and then we have to do 1 plus what is ever in that closed loop, which we don't have anything, so we're just keeping it as 1, so 1 plus GC, GP. So now we have our closed loop and our open loop. So next thing that we can do is code. So I have our code pulled up from part B. And so I put in our values that we have here. We're going to be using the Ziegler-Nicholas method for this. So I have our proportional controller as 1, our tau, which is our time constant, as 2. Our proportional gain, our proportional controller is 1, our tau I, which is going to be our time delay, which is 1 to the 6th. And then I have is GC and GP, which I did our equations that we already derived for them. And then our closed loop is GC times GP over that. So the first thing that we can do is let's make a graph for this. So I'm just going to take what we have previously made for this, since we do have the same closed loop for it. So we have this, and then we have this function here. And then let's go up here. Okay. And then we're changing in here, we're going to do GC times GP. Okay, so let's look at this right now. So we have our function up here, and we're going to a steady state. Of what we currently have, our height is going to be around 0.5. And then let's see where our crossover frequency is. It's going to be 0.87. So 0.87 on here is going to be 1.34 rounded. So that's under 1 for our amplitude ratio, which is good. That's what we want. So let's look at the Ziegler-Nicholas method up here. So we have a PI controller, and we can see that what we have is our Kp is increased from 0 until it reaches the ultimate gain, which is Cu. And then we have is the the oscillation period, which is Tu for Ku. So what we're going to use for this is we are going to find the ultimate controller gain, and then from that we're going to have an oscillation period. We're going to be using the 0.83 for that and the 0.43 for that. So to find the ultimate gain, let's just mess up these values to find where we're at. So this is unstable. Let's change this to 9. Let's see. It's still unstable, so let's change it to 8. Okay, so we're having some even. This seems pretty even. We're not going under, we're not going into the negatives, so that's pretty good. So let's see what it looks like on our crossover frequency to see our amplitude ratio, and that is just under 1, so it's 0.988. So this, I would say, is going to be our ultimate gain. So from our ultimate gain, we are going to be using that as Ziegler-Nicholas method. So we're going to multiply it by 0.45 to get our Kp. So from this, we are going to see that our Kc is multiplied by that. So now, after this, well, let's go here. We want to have our time oscillations. So we have our time oscillations, right? So we have our time oscillations of our tau and our C, and we have our ultimate gain. Now we need to know our time oscillations between the distance between the height of a full oscillation between them. So let's look at these two heights here. So we have is 11.5 and 18.7. So let's go up here to tau. So 18.5 minus 11.7. So we're going to multiply this back again to 45, and then this one here is going to be 0.83. I'm going to just double check on that. Yeah. So let's look to see. So let's look at our controller gain right now, which it is at 0.72. 0.72 is going to be, it's at 0.68. So that's within the values of it. Is under 1, and then we have this using the Nicholas method of the K and the tau I. Thank you. This is the end of part C.